Well, hey, y'all. Let's see. Just wanted to make sure my microphone was on. Hey, y'all. What's going on? Day 2 of solving systems of linear equations by elimination. So this is our third method. We did graphing and substitution last time, and now it'll be elimination. This is where we will cancel out variables and be able to solve for another. So as I wrote up here, the third method of elimination is the third method of solving systems of equations is elimination. We can eliminate a variable if they are opposites, add vertically, and they'll cancel, leaving one variable to solve for. So I put some steps up here. It's important to write both of those equations in standard form to start off. We want to make coefficients of one variable opposite. So you'll decide which one you actually want to cancel out and eliminate it. If they're not opposites, we need to make one of those variables coefficients opposite. So that's why we will multiply one or both of them. Today, if I was in class, I'd be like, is there another way we could do this? You might not only multiply, but you could actually also divide, which is, I'm going to put divide. Oh, that's, I don't know why I'm trying to write like that. Divide. Okay, which is technically multiplying. So let's say I divide by 3. If I divide by 3, it's really multiplying by 1/3, right? So kind of the same idea. So there might be some examples today that I'll use the division of something instead of multiplying. Usually it's when it's higher numbers, the dividing might go easier than multiplying. Then when we add the equations vertically, we will, from step 2, we'll eliminate that variable that are opposites. We'll solve for the remaining variable. Then take that variable and substitute back into one of the original equations, again, kind of like we did with substitution, and solve for the other. We'll write our solution as an ordered pair. All right, so solve each system of equation using elimination. The first one here is pretty straightforward because do we have a variable that are opposites? We sure do. These x's right here are opposites of each other, right? One's a negative, one's a positive. So what we're going to do is we're going to add these two together. So we're adding vertically. So -3 plus negative 3x plus 3x is 0. So that just cancels. That's the whole reason why it's called elimination, because we eliminate it. 5 plus 9 is 14. And then we have 14y. And then we have -6 -6 minus or plus 6. And that is 0. We'll divide by 14 on both sides. And so y is equal to 0. Then I'm going to have to take that y and plug it into either one of the original ones. I'm going to plug it into the second one because everything's positive there. So I would do 3x plus 9 times that 0 is equal to 6. That goes away. So I have 3x is equal to 6. And then if I divide both sides by 3, x is equal to 2. All right. What if they aren't? My last final step is to write it as an ordered pair. Okay? That is the one solution for that system. Okay, so what if I go to something like this? -7x, -9x, those aren't nice. But 2y and 2y, that's kind of nice. If one of them was a negative, it'd be even nicer because then it'd be opposites. So what I'm going to have to do is I'm going to have to multiply this by a -1. You can multiply the bottom one by a -1 too. It doesn't really matter. as long as your y's become opposites. So what do we get from there is we get a 7x minus 2y is equal to positive 21. And then I'll just rewrite the next one as it was. So those y's are going to cancel out. And I have 7x plus a negative 9x, that is negative 2x, is equal to 21 plus a negative 23 is negative 2 as well. So again, I don't necessarily always put this plus sign here because I know I'm just basically combining these guys to get to here, right? And then I solve for x. So I'm going to divide by 2, x is equal to positive 1. All right, but I need to still find my y. So I'm going to plug it into either one as well. They're both kind of funky. But negative 7x plus 2 times 1 is equal to negative 21. And then I have negative 7x plus 2 is equal to negative 21. I feel like I've messed something up there because then we're going to get a fraction here, minus 2 minus 2. And then we would have negative 7x is equal to negative 23. Okay. That would cancel that over there. And then we divide by negative 7. X is equal to negative 23 over, negative 7. So that will be positive 23 over 7. Oh, I plugged it into the wrong thing. That's why. Again, I miss being in class with you girls because you tell me exactly, like, Miss Coates, you plugged it in for the wrong thing. Duh, Miss Coates. All right. That makes more sense here now. 21. So that's negative 7 plus 2y is equal to negative 21. I'll add the 7. Negative 21 plus 7, I believe, is a 14, negative 14. I should have my calculator out. And then we divide by the 2, and y is equal to negative 7. I was like, I almost swear I had whole numbers. 1, negative 7 would be our final solution. All right, negative 21 plus 7 is, negative 14. Okay. All right. Excellent. All right, let's move on to this next one. Oh, well, this looks a little bit different than those first two because those first two are already in standard form, right? So I need to change these to standard form. So I'm going to rewrite it. I'm going to have 3x. I'm going to just rewrite the first one. 3x plus 6y is equal to negative 12. And then to get this in standard form, I'm going to need to subtract this 4y and keep the negative 20 over there. So minus 4y. So then I have 12x minus 4y is equal to negative 20. All right, so this is where they're not opposites. They're not even the same number coefficient. So I will have to actually multiply by some integer. If I look at this, 6 and 4, like the y's, are already opposites, right? Those are already opposites, but I'd have to multiply both of those by something in order to get a number to be the same, right? So I'm not going to do that. I'm going to do maybe something else. I thought that I'd be able to erase that. So if I look at the x variables, that's 3 and 12. The 12 is positive. I can make that 3 a negative 12, right? So I would multiply the top one here by, a lot of teachers put it out in front. It doesn't matter where you put it. A negative 4, because a negative 4 times negative 3 will give me negative 12. I'm going to then distribute that into everything on the inside. And I get negative 12x minus 24y is equal to positive 48. And then I have 12x minus 4y is equal to negative 20. And then we can go ahead and eliminate. These x's are going to cancel. This becomes negative 28y is equal to, I believe that's 28. And then we divide out that negative 28. Y is equal to negative 1. Now I won't mess up here when I plug it back in. I'm plugging it in for y. I think the top one might be a little bit easier than the bottom one. Again, it's kind of, actually, the bottom one might be easier as well because x is already by itself in the bottom one. So let's do the bottom one. 12x is equal to negative 20 plus 4 times negative 1. So that's 12x is equal to, that's negative 20 minus 4, so negative 24. And then I divide out the 12. So x is equal to negative 2. And my final answer is negative 2, comma negative 1. I, at times, accidentally flip-flop them around and have like negative 1, negative 2. Just be careful when you are writing your final answer, x, y. It's just natural that we do that. Okay? So that was multiplying just one equation in order to cancel out a certain variables that were opposite. All right, moving on to 4. The first one's in standard form, but the second one is not. So I'm going to rewrite it again. 6x minus 4y is equal to 20. That one's already in standard form. Here, I would need to add 6 to both sides, right? Negative 8x plus 10y is equal to positive 6. So both x and y, they're opposites, but just don't have the same number coefficient. So we won't have to multiply by a negative, but we might have to multiply both of them. Unless you're a fraction connoisseur and can multiply it by a fraction to make the x, if you needed to make the x 8 or negative 6, you can do that. I'm just not going to do that because most of you do not like fracciones. So we're going to have to multiply both of them by something. What is easier? It really doesn't matter. It's just kind of asking yourself, what's the least common multiple that I can get for one of these variables? 6 and 8, the least common multiple for that is 24. And then 4 and 10, the least common multiple of that is 20. Again, does it matter which one? No. I'm going to go with just the y's, okay? So I want to make both of these, I want to make them negative 20 and positive 20, right? So how would I do that to the first one, the top one there? I would need to multiply this by a 5 to get a negative 20. And then I would need to multiply this guy by a 2 to make it a positive 20. Did I say positive 20 less? Negative 20 and then positive 20. and distribute to both of those equations. So 5 times 6, we get 30x. 5 times -4 is -20y. And then is equal to 5 times 20, which is 100. And then we distribute the 2 inside of here. So that's -8x times 2, that's -16x. 2 times +10 is +20, and y is equal to 2 times 6, which is 12. So our y's will cancel. 30 minus 16 is 14, so 14x there. And then 100 plus 12 is 112. So 112, we would have to divide by that 14. And we get x is equal to 8. Okay. Now again, got to plug it in. I'm just going to plug it into the top one. 6 times 8 minus 4y is equal to 20. So it looks like I have a 48 here. 6 times 8 is 48. Minus 4y is equal to 20. And then I'll need to subtract this 48. So I have -4y is equal to 68. And I want to say that's going to be 17. 68 divided by 4, 17. Yeah, so y divided by the -4, y is equal to -17. So my final answer there is x, which is 8, y is -17. So those are the basic 4 ways of going about doing this. In number 1, they were already opposites. Number 2, I just had to multiply by a negative. Number 3, I just had to multiply one of the equations. And in number 4, I had to multiply both of them. So we're going to do 2 more. And you might be like, oh, 2 more, yay. Yay, but they might be maybe some special cases. So number 5. This is where I run into, wow, these are really large numbers. Can I do something else to make them like simpler? Can I multiply 1 by something or divide by something to easily get them to be the same thing? I think I can. If you notice that these are multiples of 4, right? These are multiples of 7. So I could divide those by some certain things to get something nice maybe. But if I divide by 7, this second one wouldn't be so nice, right? Neither would this be nice if I divided that whole thing by 7, right? So that's actually not going to work. Okay, so maybe think about it to yourself, could I divide just 12 and 16 by something to make it opposites? Well, we're definitely going to have to multiply it by a negative. But can I divide or multiply by its fraction to make them the same number? So if I think about that, again, 12, we have, 1, 2, 3, 4, 6, 12, right? 16. I have, and I'm looking at the factors because I can divide by those factors. And if you want to multiply and just make it big numbers, that's fine. It just is a lot more complicated. Like 12 and 16. Do you know the least common multiple between those two? Probably not off the top of your head. So 16, I have 1, 2, 4, 8, and 16. Well, look at that. I can make them both 2s, or I can make them both 4s. But looking at these equations, if I look at this first one here, let me use a different color. If I look at this first one here and divide it by 2, will those all be nice? No, they wouldn't be nice. If I look at this one right here, will those all be nice if I multiply by or divide by 2? Yes. And even going furthermore, if I multiply or divide, I might have to use a different number for both either, I don't use 4 and 4 for both of them or 2 and 2 for both of them. But this one being divided by, multiplied by, let's say, a negative 1/2, which is dividing by 2, my x becomes an 18. An 8, not 18, an 8. Can I do something to 12 to make it 8? No, unless you're a fraction connoisseur. So I'm going to have to do something else. Maybe divide this by 4. So multiply this by 4. And if I did that, my 16 would become a positive 4. Well, this guy right here, if I multiply this by, or divide this by, the top one by something, I could get a negative 4. And what would I have to divide that by? I'd have to divide it by, and so again, I will allow you to use this division symbol. I'm going to divide this by, divide that by positive 3. So it's not 3 divided by negative 12, right? I'm just dividing each of them by 3. I personally think it's better to do it as a 1/3. So I'm going to rewrite that. 1/3 times all of that stuff. And then I'm going to have negative 1/4 times all of that stuff on the inside. And just rewrite it so it kind of looks nicer. So you see if the process that I'm going with is I have to find the same coefficient. Caught myself there. First catch. 28y is equal to negative 12. So again, just to repeat myself, I need the variables to be opposites. So that's why one of them has to be multiplied by a negative. So you could have done negative 1/3 instead of a negative 1/4. And 1/4 just would have been positive. But they have to be the same number coefficient. So the same whole number, essentially. And then the negative adds on that opposite. And if I divide this orange one by 3, everything is nice. So let's go ahead and we're going to distribute in. We'll distribute, and that means we're dividing all of those by 3. So negative 12 divided by 3 is negative 4x. Negative 21 divided by 3 is negative 7y. And then negative 9 divided by 3 is negative 3. I'm now going to divide this equation by negative 4. So if I divide that by negative 4, that is going to be positive 4x plus 7y is equal to positive 3. Oh boy. They all are opposites. Boom, boom, that's 0. And then boom, those cancel out to be 0. And is that true? 0 equals 0? In fact, it is. So if we know that it's true, we used to say all real numbers, but because we're talking about a bunch of ordered pairs, it's infinite solutions. Okay? So yes, that was a little bit more tough, but you got to get the idea of I can make this the same. If I were to done the y's, I could have, it would have worked obviously the same way because you see they both canceled out. I could have multiplied by a fourth on the bottom and a negative 1/3 on the top. All right, let's try this guy here. Are we in standard form? No. You all probably said that out loud to yourselves. So how would I get it in standard form? I need to move some things around. I'm going to move this 4x to the left. So I'm going to add the 4x. So it'll be 4x plus 8y is equal to positive 18. And then I'm going to rewrite this 10x plus 20y is equal to 20. Oh, well, we kind of already did one like this. I think it was just that this guy right here. 4 and 10, the least common multiple is 20. So I want to make these guys 20. I didn't do that over here. I wanted to make these guys 4 and negative 4. I'm going to make 4x a positive 20 and the 10x may be a negative 20. So if I multiply by let's do positive 5 on that one. And then I multiply this one by a negative 5. Then that would cancel out my x's, right? So let's do that. Distribute this. Oh, no, not a 5. 5. Let's go, what? 2. A negative 2. All right, so I'm going to distribute this 5 inside. I'm going to get 20x plus 40y is equal to, I want to say that that's going to be 90. Yep. And then I have this negative 2. Come on, negative 2 to be distributed. That's going to be negative 20x minus 20y is equal to, minus 40y is equal to negative 40. Positive 40. Positive 40. No, negative. I was right. Okay. All right. Oh, well, the x's are opposite, the y's are opposite, so those cancel out to be 0. And then I have 90 minus 40, which is 50. And is that true? It is not true. So therefore, no solution. All right, not so bad, huh? I know some of you might say, well, actually, this is a little bit more complicated than substitution and graphing. It is, in fact, it makes you think a little bit more. But I will have to say, this unit is filled with word problems. So actually, our next lesson is going to consist of word problems. I might mix it up, and I'm just not quite sure yet because it's kind of hard sometimes to do the word problems over a video, but we'll see how that goes for myself, like meaning what I'm kind of going for. So we're going to have a whole day on word problems. Yes, we are. So for the following word problems, we'll define the variables. And the reason why defining the variables is important in these situations is because we have two different things, right? Set up a system of equations and solve using elimination. So, Mr. Santos, the curator of a children's museum, recently made 2 purchases of clay and wood for visiting for a visiting artist to sculpture. Use the table to find the cost of each product per kilogram. So that, remember I said this, I think back in Unit 3, I said the question, it's really not the question, but it's asking us to find the cost per product. So we have to assign our variables, basically, as the cost per product. So, X, what products do we have? Clay and wood. So basically the cost of clay, and I was going to say per, cost of clay per kilogram, and Y is the cost of wood per kilogram. I'm going to need a little bit more space. You should have enough space on your paper. Okay. So we set up our variables, defined them. Now we're going to set up the system. So it looks like he's got 1 visit. This is 1 visit. And this is a 2nd visit. And if you notice, on this section specifically, we've had everything in standard form. So this is going to be a standard form equations, or we're going to make 2 standard form equations. So we're going to do the first visit first. So first visit is 5 times the cost of clay per kilogram. Excuse me. So 5 times the cost of clay per kilogram plus 4 times the cost of wood per kilogram is going to equal a total of $35.50. All right, now I'm going to do his 2nd visit. I need 3.5 times the cost of clay per kilogram plus 6 times the cost of wood per kilogram is equal to 50.45. So right here, you should automatically say, I'm going to cancel the y's because the x's, that 3.5, that's going to cause some issues because it's a decimal. So we'll cancel out the y's. What's the least common multiple for 4 and 6? It is 12. So I'm going to need to multiply one by a negative and the other stays. So if I multiply the top one by a positive 3, I would get the y to be 12y. If I multiply the bottom one by a negative 2, I would get the bottom, the pink, as a negative 12. So we'd have positive 12 and negative 12, which are opposites. So again, you could put those numbers on the front of it or on the end of it. So let's go ahead and make some distributions. Oh, let me do that one first. So we have 3 times 5x, which is 15x. 3 times 4y, which is positive 12y. And then 3550 times 3, which is 106.50. Or 106.5, whichever you want to do. All right, now we're going to do the second one. Distribute this 2 inside. 3.5 times negative 2, I meant. So that's a negative 7x. Positive 6y times a negative 2 is a negative 12y. And then a negative 2 times 50.45. Oops. is negative 100.90 if I want to. Okay? Now I can go ahead and solve. My y's cancel. 15 minus 7x is 8x. 8x is equal to, that's going to be 106.50 minus 100.90. And that's 5.6. And if I divide out this 8, it looks like I get x is equal to 0.7. And I'm going to put a 0 there because we're talking about money here. So to the side, I'm going to have clay cost is 70 cents per kilogram. Or on your formative, I might say, what is the cost of clay per kilogram? And you would just need to put $0.70. If you put 0.7, it will be wrong because it's money we're talking about. We don't have 0.7 cents. It's 70 cents. It's actually cheap for clay because it's an outdated question. All right, now we're going to take that 70 cents and we're going to plug it into one of those. I'm going to plug it into the top one. So I'm going to have 5 times 0.70 plus 4y is equal to 35.50. 5 times 0.7 is 3.5 plus 4y is equal to 35.50. Subtract the 3.5. That is 32 over here. And 4y. Divide out the 4. Y is equal to 8. So, wood cost $8 per kilogram. So it's really not as difficult as it might seem. It's just making sure you have your standard form equations set up correctly. All right, the next one. You might look at it and be like, what in the bananas is this? Flying with the wind, a plane went 370 miles per hour. Flying into the same wind, so that means against the wind, the plane only went 325 miles per hour. Find the speed of the plane in still air and the speed of the wind. Okay, so that is our question. Find the speed of the still air and the speed of the wind. So let's go ahead and assign our variables. X is equal to the still wind, or the still speed, or still air, that's what I meant, still air. And Y is, the speed of the plane, I'm sorry. And that's the speed of, when it says speed of the plane in still air, that means if there was no wind blowing, then it would be going this speed, okay? So speed of the plane and then Y is the speed of the wind. And so you could say wind speed. So I kind of not mess that up, but you could say plane speed, wind speed. All right? So the idea of this specifically is when we're flying with the wind. Flying with the wind. Think about that. If you have the wind pushing from behind you, your speed is obviously faster. So it's pushing with you. So the plane speed is with the wind speed. So that would be x plus y. So the speed of the plane plus the wind speed with it is going to be 375 miles per hour. Now, if we go flying into the same wind, so against the wind, it's 325. So if I have with the wind, it's plus. Against the wind would be, some of you might be saying it out loud to yourself, but it would be minus. And that's as simple as it gets. Anytime it's with the wind, it's adding. Anytime it's against it, it is minus. And I always do x as the speed of whatever transportation device or transportation thing we have. So we'll do another one next time that talks about canoes going downstream and upstream, or a boat, right? Okay, so this one's pretty simple to solve because we already have some opposites. These y's are opposite. So we'll go ahead and add these together. So we'll cancel out the y's. We have 2x is equal to 375 plus 325 would be 700. And then divide by 2. So x is equal to 350. So plane speed is 350 miles per hour. And you might be like, well, Ms. Coast, that was just the midpoint of that. It doesn't always work that way. And then we need to find the wind speed. So if we have 350 plus y is equal to 375, subtract that 350, subtract that 350, and we would do y is equal to 25. So the wind speed is 25 miles per hour. Okay, so again, you might, when I said, this is bananas, at the beginning when we first read the question, in all reality, it isn't so bad because it follows this same process every time. The same process of adding the speeds together or subtracting the speeds. Okay? This next one here is a mixture problem. When we did this in Unit 3, we had to only use one variable. But guess what now? We have two variables. So we'll be able to use x and y. Not have to set up a table. Okay? But let's go ahead and read it. A clothing manufacturer has pure silk thread and some thread that is 85% silk. Who remembers what pure silk is? Pure. No, nothing cut from it, so it's 100% silk. Okay? So remember, when it says pure, it's 100%. How many kilograms of each must be woven together to make 75 kilograms of cloth that is 96% silk? Okay, so how many kilograms of each? So there we go. We need to assign our variables, define them. X is going to equal, let's do the kilograms of pure silk. And Y is equal to the kilograms of 85% silk. Okay. So in the question, it says to make 75 kilograms that is 96% silk. Okay. So 75 kilograms. So we are talking about the kilograms for one of our equations, and then 96% silk. So we're going to be talking about the percentage in another equation. So if we want to add the two, the pure and the 85 together, we want a total of 75 kilograms. So we want x plus y is equal to 75. And then we have the percentage one. So we're going to have to multiply the silks, the kilograms of silks, by its percentage. Okay, so it's basically percentage times kilograms of silk, pure silk, percentage times the 85% kilograms of silk, and then is equal to the percentage times the total kilograms of silk. So what does that mean that I just said out loud? That means 100% we know is just 1, right? 1x. Okay, so 100% times the kilograms of pure silk plus 0.85 times the kilograms of 85% silk is equal to, I want 96% of times the kilograms total. So 96 times 75. So that will always trip some people up, this part right here. But you always have to, as I said it out loud just previously, it's percentage times the kilograms plus percentage times the kilograms is equal to the total percent times the total kilograms, right? So I'm going to just rewrite this to make, because I'm going to multiply this 0.96 times 75, which is 72. Okay, so I'm just going to rewrite it here for us, which I'll do it in x. So x plus y is equal to 75. And then I have x plus 0.85 is equal to 72. All right, what variable should we cancel out? It should be pretty straightforward. I want to cancel out the x's, but I have to multiply at least one of them by a negative. So I'm going to multiply this guy by a -1. So if I rewrite that out, I have x plus y is equal to 75. Negative x minus 0.85y is equal to negative 72. So our x's cancel out there. 1y minus 0.85y is 0.15y is equal to, and then that's 3. 75 minus 72. So 3 divided by 0.15, that is 20. Y is equal to 20. We divided that by 0.15, 0.15. All right, and then it's best to just go right here and use this one, because if there's 20 plugged in here, I would just have to subtract 20 from the 75, and that would be 55, right? So we have 55 kilograms of pure silk and 20 kilograms of 85% silk. This would be the type of answer I would want to see on an assessment. I would want you to write that stuff out, okay? Because you can't just say 55 and 20 because I don't know which variable that is. Even though you defined them for me, I need you to write that out, okay? So I believe that's it for today. I only put 3 word problems. The last year I had 5 on here. So I cut it down, especially because I'm not there. And you have a little bit of homework. Keep working on the other homework. I've only heard from one person. Well, actually, I've heard from a couple people over email that I've been able to clarify questions. I appreciate that. And then if anybody needs to meet over Zoom, just let me know. Okay, you just have to schedule a time so I know I am free. 6 to 9 is typically when I'm available. Sometimes my 6 to 7 slot can be off. So just let me know and we will chat soon. I will definitely see you guys. Well, you'll see a video on Friday and I'll see you all next Wednesday.